Okay, so today we're going to look at graphing quadratic functions. Okay, so let's think through everything that we've sort of done with functions in the course of this entire school year. Right? We started functions way back in trimester 1. And we said that we could graph functions by making a table, plugging in input values, right? Getting the corresponding output values, and then making whatever that looked like on the coordinate plane. Right? And then we went into trimester 2 and we said, well, yes, that works every single time. It's great because it works every single time. But sometimes there are shortcuts that if we recognize the shortcuts makes it easier to graph. And then we learned about things like slope-intercept form, right? Where we could find M and B and just graph a line by finding M and B. Okay, so that's where we're at today with quadratic functions. Yes, we could make a table, we could plug in input and output tables, but there are also some shortcuts we can talk about. Okay, and that's sort of the process we're going to be going through today. So to identify if we're even in a situation that this works in, right, we need to know what it looks like. Okay, so a quadratic is a function that can be written, sorry, that's a typo, in the form y equals ax squared plus bx plus c. Hopefully we're all like, oh yeah, duh. We've been dealing with quadratics for a while now. Okay, when we graph a quadratic, right, just like when we pulled out the graphing calculators in our last unit, right, we got that U-shaped graph. Okay, the fancy word for that U-shaped graph is a parabola. Right, our linear functions make a line. Our quadratic functions make a parabola. Then just like I said, we can graph a quadratic just like we started graphing any function, right? We can make a table. So let's make a table over here. Okay, and let's say we want to graph y equals x squared. Okay, I'm picking good values because I know good values, right? If you didn't know, you would just have to keep picking until you could get something and tell what it looked like. Okay, but I'm going to tell you, let's plug in x values of -2, -1, 0, 1, and 2. Okay, those are the values we want to plug in today. So we said when we plug values into a function, right? Plugging in makes it our domain, right? Do you remember that word? Our domain is our x values or our input values. Okay, and we plug them into the function rule. In this case, our function rule is y equals x squared. So we're going to take each of those values and plug them into y equals x squared. So now instead of saying y equals x squared, I'll say y equals -2 squared. Right? Well, what is -2 squared?
4.
4, right? +4. Then we'll repeat that process and we'll plug in -1. What is -1 squared? 1. What is 0 squared?
0.
0. What is 1 squared?
2.
1. What is 2 squared? 4. Any questions on where those y values are coming from? Right? We then said, okay, well, if I have a table, those are then ordered pairs that we can plot. So I can plot the point -2 comma 4. I can plot the point -1 comma 1. I can plot the point 0 comma 0. 1 comma 1. And 2 comma 4. Yes, Lydia?
We've done this before, right?
True statement. That was going to be the next words out of my mouth. And some of you might be going, oh, this seems really familiar. Because yes, we actually did this specific problem in trimester 1. Okay, and so we should recognize that this looks like a U-shaped graph, right? This looks like our parabola. We are not connecting the dots, but instead we've got this sort of curved thing that continues up. Okay, usually at this point my students, okay, no problem, I'm great. Okay, we have to do a little chunk here that is now vocabulary. We're going to talk about parts of this parabola. Okay, they're important to know if we want to use shortcuts. Okay, so here's the sort of not so fun part that feels a little bit overwhelming until we sort of learn it. Okay, a parabola has something called an axis of symmetry. Okay, and whether or not you remember, this is something you've been learning about since like 4th grade. Okay, and an axis of symmetry is a line that you can draw that cuts something into 2 matching halves. Right, so a heart you can cut down the middle, right, and each side is the same.
Yeah.
A parabola has that same property, and we call that the axis of symmetry. Okay, sometimes this will also be called the line of symmetry. And so you'll see it abbreviated as LOS. Right, just like we can say X values, input, domain, right? They're all sort of the same thing here. Okay, a parabola also has something called a vertex. Okay, the vertex is the most important part of the parabola that we will be looking at. The vertex is the high or the low point. We have spent so much time this year talking about lines. Okay, and lines continue in both directions. Parabolas don't do that, right? If we have this U-shaped graph, there's a point where the graph doesn't exist anymore underneath it or above it. Okay, and that's called our vertex. If a is greater than 0, right, so ax squared, if that a value is greater than 0, then the graph is going to open up and the graph will have a minimum. It will have a low point. What types of numbers are greater than 0? I mean, 1 is greater than 0, 10. Positive numbers, right? So positive numbers make the graph open upward. We're going to even make it more specific. And the only positive number we are going to see for a today is positive 1. So if a is positive 1, our parabola is going to open upwards like a U. If a is less than 0, then the graph is going to open down. And the graph is going to have a maximum or a high point. Okay, so what types of numbers are less than 0?
Negative.
Negatives. We're going to make it even more specific, and we're only going to look at a -1. And that's going to make our parabola be upside down.
So they're basically just opposite.
Right, so it's very similar to slope, right? Positive slope made an uphill line, negative slope made a downhill line, right? This is the same idea. It's just that now we're talking about a parabola, a U shape, rather than a line. Okay, are we okay there? I know vocab isn't the most thrilling part. There are multiple ways that we can graph parabolas. So just like we had slope-intercept form, point-slope form, standard form, right? There's going to be multiple shortcuts with quadratics. The shortcut we're looking at today is this one, y equals a, and then in parentheses, x minus h squared plus k. We can write every single quadratic in this form, okay? I'm just not going to tell you how to do it. It does involve doing some stuff with completing the square, but we're just not going to do it. You just have to trust me. I'm going to give them to you in that format already. You just need to know what to do with it, okay? So when we are in this format, we can then find those specific pieces that we just talked about. Okay, x equals h is going to be our line of symmetry. So if we look at this formula, if we identify the h value, it will then tell us where the line is that chops it in half. Okay, the vertex is going to be identified by h comma k. So again, if we look at the formula and we find h and k, we will then be able to identify what the vertex is. Now, this is an important piece here. Notice that in the formula, the h is negative. Okay. And the k is positive. That's important. Because if we remember way back when we first learned point slope form, right, that negative in the formula means that this sign is part of the formula and not actually part of the number we're pulling out. Okay, and we'll see where that plays here in just a moment. We look at this next step. Okay, so the h value, or the first coordinate, the first number in that ordered pair of the vertex, is going to change the horizontal movement of the graph, which should make sense because our x-axis is our horizontal axis on our coordinate plane. Okay, so if h is positive, we are going to move right, which makes sense. If h is negative, we are going to move left, which should also make sense. The trick is that we have to know to change the sign of h from what we see in the formula. Because again, that negative is part of the formula, that negative is not part of the value that we want to pull out. K is then going to change the vertical movement of the graph, which makes sense because it's our second value in our ordered pair. If K is positive, we would move up. If K is negative, we would move down. Right? Those things all line up with everything we already know. We do not need to change the sign of K because the K has an addition sign in front of it in the formula. Okay? Okay, and usually at this point my students are like, okay, Mrs. McKinney, that's a lot of info, I'm not really sure. Like I said, it all comes together nice and neat. It nice and neatly all intertwines, and you don't even have to think about all of those individual pieces. Okay, so let's look at what we actually do here. Ooh, I have to make this a little bit smaller to get this to fit, I think. Okay, so our rule says that we have a quadratic. Okay, a quadratic makes a U-shaped graph. We have a parabola, and we're shifting it right and left, up and down, or flipping it up and down based on A. Right? Those are the three things that we've been talking about: horizontal movement, vertical movement, and whether it opens up or down. However, no matter what, the parabola is always based on its original form. The original form was that when we had our table, if we moved over 2, we went up 4. If we went over 1, we went up 1. It's still going to be based on this original one. We're just moving it around in the quadratic plane. Okay, so if we're asked to graph this, the first thing we are going to do is we are going to identify the value of A, the value of H, and the value of K. Remembering that A is always the number in front of the parentheses, right? That's what the formula told us. So what number is sitting there in front of the parentheses? 1. H is always the number inside of the parentheses, but we have to take the opposite sign of it. So it's positive 4, right? So H is positive 4. And what is K going to equal? 2. From that info, we can then find the vertex. We said the vertex was H, comma, K. So what is our vertex going to be in this problem? Right? 4, comma, 2. So on the coordinate plane, I am going to plot a point at 4, comma, 2. Now watch when we plot. You do it without even thinking about it. We are horizontally moving 4 and vertically moving 2. Right? So that's taking care of our H being our horizontal movement and our K being our vertical movement. Okay, so worry about the construction up here. Okay, so that took care of all of our H and K in one thing, just by plotting a point. Okay, we are then going to decide, does this parabola open up or does it open down? Up, because A is positive 1. So we know that this is an upward facing parabola, which means it should look like a U. To get the other points on our parabola, we are going to go back to the original parabola rule. That said, if we move left 2, how many should we go up? 4. So from our vertex now, not from the origin anymore because we have a new parabola. From our vertex, we are going to move left 2, up. I can count 1, 2, 3, 4. From our vertex, we should also move left 1, up 1. So now I'm going to move left 1, up 1. It should then not be a surprise that I am duplicating that exact same process on the other side because it has a line of symmetry that chops it perfectly in half, which means now I'm going to move, 0, 0 is nothing, right? That's the point we already plotted our vertex. So now I'm going to move right 1, up 1. So over here I'm going to go right 1, up 1. And then I am also going to go right 2, up 4. Okay, I can then do things like identify the axis of symmetry. So what is our axis of symmetry? Remember what we said it was? Okay, we said it was x equals h. It's the line that cuts it in half. So x equals what in this problem? 4. And wouldn't it make sense that that vertical line right here is chopping that in half? You are going to have to do one more thing. You're going to have to give me a point and a symmetric point so I can tell that you actually graphed it and you didn't just draw a random like whoop, right? I want to make sure that it's actually what it should be. What does the word symmetric to something mean? What does symmetric mean? Like in math terms? Olivia? No? Right? It's the same image, right? If we were to fold this in half, it would fall right on top of itself. So what point would be symmetric to this point?
The one, right?
Right? This is symmetric to it? What point would be symmetric to this point? The one to the right of it. Okay, so you can either choose to name these 2 points or these 2 points. I don't care. But you'll have to name them. So we could say that this is a point of 3, 3. And symmetric to it would be the point 5, 3. It just tells me that you actually knew where those points should go and you didn't just guess. Right? You didn't make something that just sort of looked like a U and hope for the best. Okay? And then again, at this point, my students are still kind of like, oh my gosh, Mrs. McKinney, I don't know, right? Sort of the same place we were with completing the square. Like I said, just take a deep breath. It's okay, it gets better. So now let's look at the next one. I'm going to choose a new color. So let's graph this one. The second one. What does A equal? -1. What does H equal? +2, because we take the opposite of it.
And then -3.
What does K equal? -3, because we don't take the opposite of K. Is this parabola going to open up or down?
Down.
Down, because A is -1. What is our vertex going to be?
2, -3.
2, -3. So we're going to plot a point at 2, -3. And then how many am I going to move from this point?
Negative.
I'm going to move left 2, but do I want to go up 4?
No, down.
No, I want to go down 4. Right? So I'm going to go left 2, down 4. Then I'm going to go left 1, down 1. Right? Left 1, down 1, because it opens down. Then I'm going to do the exact same thing on the other side of it. Okay, so I'm going to go right 2, down 4. Right 1, down 1. Here's an odd question. If I were to move right 3, how many would I need to go down?
Wait. Oh, 3 squares. 9.
9, right? Because it's a quadratic. 3 squared is 9. So if I were to move right 3, I'd go down 9. If I were to move right 4, how many would I go down? 16. Right? Because all I'm doing is squaring those numbers. Yes, Olivia?
I don't get how you're knowing where to move the dots, but the dots.
How to move this dot right here or the other dots around it?
How you got any of that besides the vertex? I don't understand anything else.
Okay, so all I'm doing is squaring. I'm saying if I go over 1, what is 1 squared? 1. And so because it opens down, I'm moving down. So Olivia, you're not a memorizer. You're someone who's like, I want to understand what's happening. That's what's happening. I'm squaring that value. Okay? If you are a memorizer, it is the same thing every time, so you could just memorize it as well. Okay? But it's just however, right? If you were to move over 17, you'd go down whatever 17 squared is. Okay?
So you could keep going forever.
Absolutely. Just like a line, you could keep going for forever. Yes?
Is the h ever negative?
Yes. And we're going to look at some of those.